So today we will continue with the topic of radicals, and today we are going to start with those mathematical operations with radicals. The first one we will see is addition-subtraction. So the first thing that we need to see here that in order to be possible to add or subtract radicals, they must have the same index. Remember, the index is the little number outside the radical sign, and the radicand, that means what is inside the radical. So that means that only the coefficient, the number outside the radical, is going to be different. But the index and the number or letters inside the radical must be exactly the same. The steps are going to be very simple. First, if the radical is not decomposed and simplified, we will need to decompose and simplify the radicals. And after that, we will add or subtract the radicals that have, as we told, the same index and the same radicand. We only add or subtract the coefficients, and the index and the radical stays exactly the same. So let's see some examples of addition and subtraction of radicals. The first one is going to be very simple. We have 3 square root of 2 minus 5 square root of 2. So in this one, of course, the radicals are exactly the same. The index is squared. The number inside the radical is number 2, so we can add or subtract the coefficients. In this case, 3 minus 5 equals minus 2. So that means this specific 3 minus 5 is going to be minus 2 that multiplies the square root of 2. And that will be my answer. So as I was telling you, this one is very simple, but the idea is the radical must have the same letter, number, power, etc. inside. It must have the same index, and the only one that we are going to add or subtract are the coefficients of those that are exactly the same. So let's see other example. So on this one, remember, we must add those that are exactly the same in index and radicand. So that means we have square root of 7 and we have square root of 3. So those are like terms, so they must be added and subtracted. So it's going to be, let's start with the root of 7. So it's going to be 4 root of 7 minus 6 root of 7. It's going to be minus 2 that multiplies the root of 7. What happens with the other one? It's going to be minus 2 plus 9, it's going to be plus 7, the square root of 3. Of course, this one is our answer, but we can order it because we have a binomial in our answer. Our answer is a binomial. Remember, in a binomial, we must put first the positive, then the negative. So correctly ordered, it's going to be 7 that multiplies the square root of 3 minus 2 that multiplies the square root of 7. So this one is going to be our final ordered answer, because remember, when we have a binomial with a positive and a negative one, we must write the positive one first. So let's see other example. So on this exercise, it's going to be also very similar. We have two of them that have exactly the same index, in this case the cubic root of minus x, and two of them that are exactly the same, in this case the fourth root of x. So let's see, 8 plus 3 is going to be 11 that multiplies the cubic root of minus x, minus 2 and plus 6 it's going to be plus 4 that multiplies the 4 root of x. Let's see here, because we can do an extra step. Remember, when we have an odd index of a negative, it's going to be always a negative answer, because the only possibility is minus multiplied by minus multiplied by minus. So in this case, on this one, we can take out the minus sign and we can put it like minus 11 the cubic root of x plus 4 the fourth root of x. Here, of course, we cannot add them because the index of this one is 4, the index of this one is 3. We have a binomial with a positive and a negative one, so we must put the positive one first. So the correct answer of this one should be 4 that multiplies the 4 root of x minus 11 that multiplies the cubic root of x. And this one, it's going to be our final and ordered answer. So remember always when we have a binomial with a positive and a negative one, the order must be first the positive, then the negative. Let's see other example. So on this one, the first thing we need to do is, in this case, we can need to decompose and simplify the radicals because they are not decomposed. So let's see. The first one, 27, it's going to be 3 cubed that multiplies x to the 4. The second one, the 250, we can decompose it. 2, it's 125. 5, it's 25. 5, it's 5. 5, it's 1. So this one is going to be 2 that multiplies 5 cubed, x cubed, y to the 4, minus 8 that multiplies 3y cubed, x to the 4, minus x that multiplies the cubic root, and let's see the 54. 2, it's 27. 3, 9, 3, 3, 3, and 1. This one is going to be 2 that multiplies 3 cubed, y to the 4. So let's see. On the first one, we can take out a 3, we can take out an x, and in the inside part, I will have only a 3. The x goes 2 times outside because 4 divided by 2, it's 2. 3 divided by 2, it's 1, and 1 is left inside. What happens in the other one? In the other one, it's going to be, we can take out a 5, we can take out an x, we can take out a y. In the inside part of the cubic root, still a 2 and a y. What happens in the third one? Minus 8, we can take out 2 x's, 1 y, and in the inside part, it's going to be 3y, and on the other one, it's going to be, let's see, what can we get out? We can get out a 3, and we can get out a y, and in the inside part, going to be the cubic root of 2y. So let's see. We must add those that are exactly the same. Those that are like terms only, it's this one and this one, because both of them have the same index, that it's cubic root, and inside 2y. This one that it's here and this one that it's here, they have the same index. Both of them have 3, but this one have y. So those two are not like terms because they cannot be added because the inside of the root it's not exactly the same. So on this one, it's going to be minus 5 minus 3, it's going to be minus 8 xy that multiplies the cubic root of 2y. And what happens on the other one, it's going to be, of course, minus 8 x squared y that multiplies square root of 3y. Finally, plus 3x squared y that multiplies the square root of 3. And this one, of course, it's going to be our final answer. What is that my order? First, I put the one that it's bigger, the cubic root, it's bigger, so that's why I put it first. Between this one and this one, both of them are the cubic root, but this one it's a cubic root of a number and a letter, and this one it's only, a square root of a number and a letter, and this one it's a square root of only a number. That's why this one comes first and this one goes at last. And this one is going to be my final answer. Let's see other example. So let's see this exercise. All of them are cubic root of negative numbers. So maybe the first step we can do is we can take out the negative sign from the inside of the roots, and it's going to be minus 6 that multiplies the cubic root of 108. Then it's going to be positive 3 over 10 that multiplies the cubic root of 625, minus 2 over 7 that it will come a plus that multiplies the cubic root of 1715, plus it's going to convert to minus 1/4 that multiplies the cubic root of 32. So after changing the signs, I need to decompose the numbers. 108 divided by 2, it's 54. Divided by 2, it's 27. Divided by 3, it's 9. Divided by 3, it's 3. Divided by 3, it's 1. So this one is going to be the cubic root of 2 squared that multiplies 3 cubed. The next one is going to be the cubic root. Let's see. 625. Can decompose it by 5. And it's going to be 125. Decompose it by 5. 25. 5. And 1. So this one is going to be 5 to the 4. Then it's going to be 2 over 7 that multiplies the cubic root, and let's see. Divided by 5, 343. Divided by 3, it's going to be, it's not possible to simplify it by 3. So by 5, it's also not possible. So let's try 7. It's going to be 49. 7, it's going to be 7. 7, it's going to be 1. So this one is going to be 5 that multiplies 7 cubed. And finally, minus 1/4. And 32. It's going to be 2, it's 16. 2, it's 8. 2, it's 4. 2, it's 2. 2 is 1. So this one is going to be the cubic root of 2 to the 5. So let's take out what we can take out of the roots. So this one is going to be minus 6. It's possible to take out a 3. So it is going to be minus 6 that multiplies 3. And in the inside part, 2 squared, it's 4. Then it's going to be 3 over 10. Here it's possible to take out a 5. And in the inside part, it will have 1 5. Then it's going to be 2 over 7. It's possible to take out a 7. In the inside part, going to be 1 5. The other one is going to be 1/4. That multiplies, here we can take out a 2. And in the inside part, going to be 2 squared, or 2 times 2, that it's going to be 4. So let's see, it's going to be minus 18, the cubic root of 4, plus here 5 and 10, we can simplify it. 5 and 10, it's going to be only 2 on the bottom, so it's going to be 3/2 of the cubic root of 5. Then it's going to be 7 and 7, so it's going to be plus 2 the cubic root of 5. Then it's going to be minus, and it's going to be 2 and 4, it's going to be only 2, so it's going to be minus 1/2 of the cubic root of 4. So after this one, let's check if we got like terms. Of course, we have like terms, this one and this one, because both of them have the same index, 3, and the same radicand, that it's 4. And of course, this one and this one are also exactly the same. So in this case, it's going to be minus, let's start with the ones that are positive ones because they will go first. This one, 2 are negatives. This one, 2 are positive. So we know our answer is going to be a binomial with a positive and a negative. So let's start with the positive part. We have 3 halves plus 2. So let's do it here. Maybe you can do it by mind. But 3 halves plus 2. 2, it's like having 4 halves because 4 divided by 2, it's 2. So it's going to be 7 halves. So it's going to be 7 halves of the cubic root of 5. Let's see the negative ones. It's going to be minus 18 minus 1 half. So minus 18 is going to be minus 36 halves. Minus 1 half, it's going to be minus 37 halves of the cubic root of 4. And that's going to be my final answer. Of course, we put first this one that it's the positive. After that one, we put this one that it's the negative. So the idea is basically the same in all the exercises. Decompose and simplify the radicals. Add, subtract those radicals that have exactly the same index and radicand. And of course, the answer must be ordered. That's it for today's topic, that was addition, subtraction of radicals.